Alright, good afternoon everyone. Welcome to Sec 4 E-Math lesson with teacher Jason over here. Alright, just before I start the class, okay, there's actually a carnival going on. So what happens is actually today from 17 to 19 March, it's already happening. In fact, it has already passed 2 hours. So hopefully if you have some time, you can take a look at the carnival there. It's at United Square, so there's a Novena at the basement floor. So there are some activities to earn bubbles and freebies as well. Sorry for that. Okay, as well as there are some games. So for interested to know, interested to follow up as well, you can do that. And lastly, if you're wondering how I am teaching in the studio, you can take a look as well. There's actually a studio tour. So head down over there and yeah, you may be able to understand how I deliver my content to you guys as well. Lastly, if you're a fan of food, there's free popcorn and some activities over there by Balloon Scouting. And over here, there are some exclusive offers for that. So head down if you want to have a good de-stress session for the learning carnival ahead. Alright, now for that, what happens? Some general rules before I start the lesson ahead. Just be patient and understanding along the way when you're typing. Some of you are actually a bit shy, but feel free to type more. But when you type, just make sure that everyone is together learning the same content. So observe your behavior, be gracious and respectful. Lastly, along the way, try to ask good and relevant questions, or in fact, we maintain from there as well. Alright, so what are we learning for today? So today we are going through vectors. So again, a lot of recap on the vectors that we have gone through. And what happens, we are going to learn how we add and we subtract vectors. And what is the notion when we actually do them. Alright, so first up, a few recaps over here. Let's recap. A vector, what is a vector? So recall that a vector, it's a quantity with both magnitude and direction. So it's not just a number, but we need to know what is the particular number that we are talking about and which direction is moving. Okay, so in this case, when we talk about a scalar quantity or vector quantity, some examples, scalar distance is an example, speed as well, because we are talking about how far and how fast, but where are we moving? Okay, that's where we talk about displacement and as well as velocity. Alright, so these are some examples of scalar quantities and vector quantities that we can talk about when we talk about scalar or vector quantities. Now, how do we then represent a vector? Hopefully this is clear. Now, a vector, take note, we use a line segment and it is directed. Take note, a line segment that is directed. Whereby, what does it mean? Okay, what represents the magnitude is the length of the line. And what represents the direction? It's the arrow on the line. So in this case, for this particular example, my arrow is going this direction from A to B. Alright, so from A to B, what does it represent? Okay, or how do we represent it? In this case, sometimes we can represent with a small letter A, or sometimes or it's bolded, but sometimes it's a little bit hard to bold on our side. So what we do, we can say, oh, we write the vector AB and it is going from A to B. Take note, our arrows is always going from one to the other side. So left to right from the arrow head. And as well as we can write the letter and the curly arrow. In this case, a letter and a curly arrow to denote the vector. Okay, where A in this case, what do we call? We call this the starting point. Or we call it the initial point. B, what do we call it? In this case, the ending point and the terminal point as well, or the terminal point as well. So again, some representations that we can take note of. Now, in this case of vectors, how do we represent them? Let's recap. In this case, we are only talking about x and y axis on the Cartesian plane. Remember, you only have x and y axis, or the other way around. Okay, so we usually represent it as a column vector x and y, where in this case, what do we know? X is the number of units we travel along the x-axis. Y is the number of units we travel along the y-axis. Now, this is known as the vector. How do we know how long it is? Let's recap. To denote a magnitude, we have these two lines over here to represent them. And the vector AB, or in this case, if sometimes we represent with the alphabet and the curly sign. So vector, the letter, and then just the curly sign over there. And what do? We calculate using the Pythagoras theorem. Alright, so it's the Pythagoras theorem that helps us understand how long the vector is. Alright, and how do we actually calculate how long the vector is? Pythagoras theorem, recap, in this case, we take, in this case, let's say if I move to that direction, take note the arrow is moving from here, this direction. So how do we read it? In this case, this is my x. Okay, in fact, let me use a highlighter. It might be a bit clearer. Let me use a highlighter. This is my x. This is my y. So in this case, if x is here, y is here, right angle triangle, that's where my Pythagoras comes in. X squared plus y squared, and I need to square root my value to find this particular length down here. And talking about that, just two more concepts before we move on to our content for today. Just bear with me because there's a lot of vectors content that we went through last week, and all of them are important. Equal vectors, alright, this is similar to matrices again. Two vectors are equal. Again, what do? They have the same magnitude and direction. Okay, same length, same direction, then we say they are equal. Or in fact, if we zoom into their particular entries, that is where it's similar to your matrices. If both of the vectors are equal, if you look at the top, then these two vectors are equal. Sorry for that. Similar for your matrices, we talk about the corresponding entries to be equal. A is equals to C and B is equals to D. Sorry for that. If I were to talk about the entries over here. Alright, if I were to talk about the entries over there, that is what we actually mean. And lastly, what happens? We have equal vectors, but sometimes we need to know what's the notion of zero. So what happens? Zero vector, again, we say it has zero magnitude, and no direction. Okay, it's known as a bold zero, but what does this bold zero mean? Following the curly arrow with the zero, and as well, x is 0, y is 0 at the bottom. Take note, it is not a scalar, but in this case, it's represented as a vector. Alright, so finally coming to our concept, because all these links to addition. So in this case, for any two columns, if we were to add them, this is A, this is my vector A, this is my vector B. If we were to add them as such. Now, let's focus one by one first before I go through. This is more or less like a recap on matrices. What will be the entry at the top? Come, type your responses. What will be the entry at the top over here? Let's try it out to see whether I can gather some responses over here. Very good, Denise. Anybody else still wants to try? Fion, you want to try again? It's not. Very good, Ian. Perfect over here. Fion, you want to try again? Alright, perfect. Good job, good job. Any other responses that I have over here? Okay, so the top one, very good. I think most of you got it. In fact, Ian and Denise, good job over there for giving me both. Top one is just P plus X. Bottom one, I'll give you another try. What will be the bottom one over there? What will be the bottom entry? So in this case, I'm talking about very good, Zing. Perfect job over there. Anybody else who wants to try? Very good, Fion. Good job over there. Doing very, very nice job over there. So in this case, it's just Q plus Y. Okay, again, this is very similar to matrices. If you add the top, the bottom will add up as well. Right, now with this, let's come to a work example over here, shall we? So A plus B. Again, if it's bold, please do not do this. I don't want you all to shade. No, don't bold. Just A curly plus B curly. Okay, both representations. Please do not bold until you spoil your paper. Okay, now what happens? This is going to be 1 and -4 plus 8 and -3. Again, what we have mentioned is just going to be top summing the top, bottom summing the bottom, adding them up. You are going to get very nice thing. Perfect. Those are both my entries over there. 1 plus 8, -4 plus -3. In this case, -4 minus 3. Very good, Ian. I think you are getting it. But make sure when you write the actual matrix, it's going to be over there. Okay, do not have the line. But understand in terms of writing it, it's hard. It's going to be 9 and -7. Okay, so this one should be quite straightforward. But doing a good job over there. Good job over there. But now, awesome. Yes. Good job, Ian. Perfect over there. I understand what you mean. Okay, now since I feel this a little bit straightforward, let's see how we actually tackle this question. Alright, should be quite fast, so only 30 seconds. So get your pen and pencils ready. Launching the bubble launcher in 3, in 2, in 1. Let's go! Alright, doing good. Okay, very nice, very nice. Seems like a good response over here. Okay, be careful if you're adding. Alright, I have negative 1. Okay, let me just not say anything. Be careful if you're adding. Okay, so when I'm adding vectors, just be careful what I'm doing over here. P plus Q. Okay, 5 more seconds. Okay, no worries, Zing, no worries, alright. You can go ahead to your break which you need, toilet break that you need. Alright, time's up. Let me take a look. Okay, not too bad. 70% of you all got it. That's a good sign. But for the rest who didn't got it right, just follow over here. Don't worry about it. We all learn together. Alright, so let me take a look. Now, P plus Q. Negative 5, negative 1, plus 7 and negative 4. Alright, now how do we actually do this? In this case, just add them together. Negative 5 plus 7, negative 1 minus 4. Okay, that's where when you add up, okay, negative 5 plus 7 is going to be 2. Okay, some of you, I think you're at 5 plus 7. You all forgot the negative sign. Okay, and in this case, negative 1 minus 4 is going to be negative 5. Alright, some of you actually did plus at the bottom, negative 1 plus 4. So you might mix up the signs. Or in fact, you might have written the vector wrongly. So that's why in this case, my answer is 3. Okay, so just make sure you are adding back. Alright, welcome back, Zing. Alright, focusing from there. Now, what happens is, okay, how do we, or what is the meaning of doing your vector addition? So right now, we know summing the entries is like this. But what does it actually mean to sum up the vectors? So let's investigate together. So from the previous work example, we figure out that my vector is actually this. But what does it actually mean, or what do we notice when we actually draw the vector? Okay, so let's say I draw this vector over here. Yes, so you realize when we draw this vector over here, we follow a particular concept that is shown. Okay, so what I will do over here is, first, what I will do, I will draw my first vector A first. So in this case, 1 and negative 4. So you realize over here, this is 1. This is negative 4. Okay, because this is 1 is negative 4, but I'll write 4 first because it's going down. Don't worry about it. Yep, that's right. The sum of the two vectors will give me my vector. To be more specific, you call it the vector. You are not allowed to call it a matrix, but for here it has direction. So we denote it as a vector when these lines are drawn. Alright, thank you for the note, Denise. That's a very good question. There's a very good note over here. Now, let me just draw my vector properly. So that's where I will utilize this one over here. Yeah, so 1 and negative 4. Yeah. So this is my vector A. Alright, this is my vector A. 1 and negative 4. And then from there, I have 8 and negative 3. So from here, again, this is my 8. And this is my 3. Okay, half a box is 3. So let me just draw my line. Just give me a moment. So 8 and negative 3. So 8, 1, 2, 3. Just give me a while. It will take me a while to draw. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Okay, it should be here. Okay, now what is the vector I'm getting? You realize? Okay, let me just draw. If I were to draw, you will get 9 and negative 1. So let's see our vector, shall we? So our overall vector should look a little like this. So if I were to draw a line down, should be this way. And my vector, let's see whether it is 9 and negative 1, shall we? Okay, because it should follow the root. So you realize how I draw the vector. First one, I draw A. Then from the endpoint of A, I draw B to give me my vector A plus B. Which do, in fact, if we were to calculate, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9 units in this direction. And downwards, 1, 2, 3, 4, 5, 6, 7. 7 units downwards. So what do you notice about this vector over here that I have? Okay, is that if I were to draw out as such, okay, from A downwards and I go to B. So I draw A, from the endpoint I go to B. you realize I get my overall vector A plus B, which then explains how we actually add vectors over here. So what is the meaning of adding vectors? So if I'm adding vectors, it's not just the numbers, but if you follow our animation down over here. Now you take a look at my, okay, sorry for that, let me take a look. Okay, give me a moment, there might be a little error. Okay, so, okay, my animation is not added. Alright, so just give me a little moment. I'm actually going to add the animation, so I'm just gonna close this screen for a little while. Alright, don't be shocked, alright? I'm just gonna close the screen a little while to actually make sure that the animation is shown, so don't be shocked if you see a little white screen over there for a while. Alright, so just give me a little moment. Alright, don't worry about it, everything is fine. It's just that I need to sort of get this inside. Alright, so just give me a little moment. Alright, okay, so meanwhile just try to understand what we have over here. Okay, again, just give me a short while. Okay, just a little while to sort of bring the notion in. Alright, stay calm. Alright, I'm gonna bring the notion in. It's gonna be like a short while, so just bear with me. Alright, okay, just bear with me for a while. Okay, meanwhile, just do a little recap on what we are supposed to do as well. Okay, so just take note of what we have over here. Just give me a short while, guys. Alright, stay calm. Okay, everything is fine. Just make sure that we do a little notion on the vectors that we have. Okay, just give me a while. Alright, okay, give me like 2 to 3 minutes to make sure I find the particular animation to show you. Okay, so stay calm. Just give me a while. Okay, give me a while. Yeah, sorry for that. Sorry for the technical notion over here. Just give me a short while to actually get things right for you. Okay, right now, so okay, just give me a little while. I'm almost there. Okay, give me a while. I'm almost there, guys. Don't worry about it. I'm almost there. Okay, just give me a little while, alright? Alright, okay, sorry for that. I am now back. Okay, sorry for that. Okay, now let's see with the addition. Okay, I'm now back, guys, so come back to me. So now let's see, what does it mean to add my vectors? Alright, what does it mean to add my vectors? Now, let's say I want to find AC. I want to find AC, alright? So what happens is this, I have A. I want to go to C. So A to C, what does it mean? Okay, I'm going A to C. So if you follow the dot over there, there's going to be a dot that appears. The dot will travel from A to B, and after that B to C. So what does it mean? It is actually following the direction, and they have to have a common point, A to B, B to C. So what does this vector give? If you realize it's just P and Q, so overall giving me AC. That is the notion over there, AC. Alright? That is how we add vectors. Cool? Alright, next up, following up nicely, what does it mean to add vectors if you follow the animation correctly? Again, following this notion over here, AB plus BC. Okay, again, is to follow the notion of adding vectors. What do we get? We get, in this case, again, let me just check. Okay, sorry for the note over here, the arrow is not correct. Okay, it's going to be the other direction. Because it's AB to BC, so this one is going to AC. Alright guys, AC. So AC. That's the notion P plus Q. Or P plus Q in this case is going to be R. Okay, R over here. In this case, AC over here, what will it be? We call it our resultant vector. And lastly, usually the resultant vector we use as a double arrow. So again, how do we draw this particular vector in terms of vector addition? So starting, remember what I did for you for the investigation? Exactly what I did over here. So firstly, we draw vector A on a sheet of graph paper. Endpoint of A, we draw vector B, and we draw a directed line segment, A plus B. Again, just to refresh your memories over here, okay, I have vector A, I draw it out first. From the endpoint of A, I draw B, then after that, I draw the yellow line. Of course, to make sure that you draw correctly first, guys, before we go on to drawing out everything over here. Okay, now, next up. Again, why is it not here? Again, sorry, let me just do the notion over here. Okay, again, now, for the law of vector addition, again, let me just do a bit of magic over here. I apologize again. Let me just insert the video down. So I hope you guys got the notion, but let me just add the video down first. So I'm gonna disappear a bit and add the video down. So just bear with me for a while. Sorry for that. Just bear with me for a little while. In terms of the notion of the video, and yep, I am appearing again. Alright, so a lot of magic done today, but do not worry about that. Every content is there. So now, just now was the triangular law of vector addition, because you see a triangle. But what is for the parallelogram law? Why do we need it? Because sometimes when we do the parallelogram, okay, the vectors are not really drawn, say, very nice. So AB, AC. Now what happens? We want to find the resulting vector AB plus AC. Let me just pause a little bit and rewind accordingly. Now if we were to draw it this way, AB plus AC. Okay, AB plus AC. You realize we cannot get any resulting because A to B is here. But I cannot go anywhere from B. It's stuck. If you recall from triangular law, there's somewhere for me to go from A, right? This one, I'm stuck here. I need to do something. So what happens? Over here, because it's parallel, so I shift that vector there. Remember, because it is the same direction, same magnitude. So therefore, I can shift it there and call it the same vector. And therefore, because they are the same magnitude and same vector, they are equal vectors. What we have kept just now, equal vectors. Same magnitude, same direction. Therefore, I can shift them. So now I can do it. AB plus BD. This is my resulting vector AD. Okay, this is one of the reasons why parallelogram law is used. It's very formed because what happens, we can actually form a triangle, but it's still good to know just in case my vector, let me just rewind a bit, starts this way. If it starts this way, I cannot draw. So I need to draw a parallelogram. Why is it a parallelogram? It's not really a complete parallelogram because I'm just missing a line here. But if I have to complete a line here, it is a parallelogram. But in this case, this is not needed because we just want to find the resulting vector. Alright guys, I hope this is a little clear for you all, and let me just get some feedback for you all to see whether you guys actually understand it before I move on to my work example. Alright, so just make sure that I'm getting a clear understanding over here. Okay, so a bit of yellow and green, that's good, that's good. Okay, there's a little red here. So red, if you don't really understand, I hope this work example makes it clear. Okay, so again, just make sure if there's any queries, just let me know. Alright, okay, I'll just get some more feedback. I'll just wait for 20 more seconds before I carry on with the work example. Okay, alright, seems like it's more green, but if there's a little bit of yellow and red, alright, just let me know if you don't understand after there's a Q&A later. Alright, now, how do we actually simplify our vectors? Okay, let's take a look. So let's simplify these vectors first. So BD plus DC. Again, first write down my vectors first. Write down the equation. So simplify BD plus DC. Okay, let's look at the diagram, okay? BD, what is it? Highlighter or anything to help you. BD. Okay, and then DC. Right, so it goes this way and this way. And does anybody want to try BD plus DC? What do I have? Come, type down your responses. What will I have over here? Very good, Ian. Perfect job. Anybody else wants to try? Over here, BD plus DC. What will I have? Okay, very good. Alright, but try not to confuse yourself over here, Denise. Just go from left to right, okay? Very good, doing perfect job over there. Anybody else wants to try? Okay, in this case, what do I mean for Denise? In this case, just draw from... Very good, Jinrong. That's actually perfect over there. So that's where you realize I go from the simplest direction, B, C. So this is my final answer. Okay, but let's say what happens. Yep, that's right, Denise. We always go from the right. Take note for vectors, we always draw in the direction this way. Alright, but you guys are doing good. You guys are doing bad. So keep up the awesome attitude over there. Alright, now what happens is, suppose let's say we have 3 vectors. How do I do it? So CA plus AB plus BD. Again, don't panic. If there's 3 vectors, do 2 by 2. Alright, do 2 by 2. It will be easier for you all. So first step, we go from left to right. Alright, always remember, just like when you solve equations, left to right, like a board mask, left to right, the order. Again, left to right. First step, CA plus AB. Okay, now what happens? CA plus AB. What is the overall vector we have over here first? CA plus AB. CA plus AB. What do we have? Very good, Denise. Okay, if you want to take note, is it gonna be that way? CA plus AB. What is the direction? You got the vertices, right? You got alphabets, right? Sorry, not vertices, alphabets. Okay, CA plus AB. Okay, understand the way we write the vector is not very nice. We'll write it this way. Okay, sorry, it's supposed to be 1 arrow. Okay, but in this way, you realize what do we have? Very good. Yes, okay, that's right. Okay, so in this case, we get C to B. In this case, C to B. Then afterwards, you realize because this is CA plus AB, we get C to B. Now, next up, follow up C to B plus BD. Okay, now, first up, we know, okay, simplify further. CA plus AB, we know is going to be C to B. Okay, that's the vector we know. Next up, what do we get? Perfect, Zing. Awesome job. Anybody else wants to try? Let's see whether you can finish faster than I draw the vector out. I think you all can, because I'm seeing good responses here. And afterwards, this gives me over here. Alright, so what do we have? Where are you sure is that notion? Take note. Is it arrow left? C to B plus BD. The vertices are correct, but is it to the left arrow, Denise? Okay, take note, in this case is C to D. Very good job. You guys are doing good. You guys are making sure that you got the content now. Very good. Okay, so now it's C to D. Okay, so in this case, what happens? You realize this is one way whereby we can just add the vectors directly like this to give me CD. But next up, you realize, if I look at this, you may wonder, isn't this the same example as the one that we have for part B? What is the difference between part B and part C? Now, if we take a closer look, what is the difference between part B and part C? First step, you realize now AD plus BC plus DB. Alright, remember what I said. Let's solve from left to right. Okay, shall we? Left to right. Now, first step, we try. Okay, first step. AD. And then you realize plus BC. Then you realize, I cannot do anything. AB is here. BC is here. There is no direction. So, does it mean that it has no answer? Think about it. How do we simplify even further for this? I give you a clue, there's an answer for this, but how do we rearrange? Yeah, we can actually do BC plus DB first. In fact, what happens? If you were to rearrange like this, correct, Zing? I think you will get something. So you can rearrange and do BC and DB first over here, because this is how I connect my vectors. Or in fact, that is where sometimes you have to do this thing called rearrangement. So you realize if I were to piece these 3 vectors together, which 2 vectors can I pair together first? Yeah, should be 1 arrow, sorry for that. Good note, Denise. Good note over here. Let me just draw 1 arrow, 1 arrow, 1 arrow over here. So which 2 vectors should I pair with first? Okay, let me just draw. Which two vectors should I pair with first to make my life easier? Let me just indicate the arrow. 1 here, 1 here, and 1 here. right? Pink and AD. Good job, Denise. All right, so in this case, what Denise meant is AD plus DB. Or in fact, you realize if you were to recall from the direction, they have common vertices over here. So that's one way you can think about it to see whether we can pair them like this. So here, AD plus DB. I hope you all realize in this case, you are getting this vector AB. That's the first step. And then you realize, okay, AD plus DB, you are going to get similar notion as now question 2. You're going to get AB. AB plus BC. Okay, let's see whether you know this. AB plus BC. What am I going to get? Very good, Zing. Anybody else wants to try? Anybody else wants to give it a shot? AB plus BC. What will I have? Very good, Ian. Perfect job. In this case, AC. Alright, so what's the moral story here? First one, straightforward, 2 vectors. Can be 3 vectors. No need to rearrange. Last one, you have to see whether there's any possible way to rearrange. Very good, Denise. To see whether we can get the overall resultant vector. So there are 3 things we need to take note here. Alright. Now, let's see how we pair this up. Bubble question 2. Okay, looks very tedious over here, but let's see how we can do this. Okay, simplify the vector PR plus RS. Okay, what do we have? 30 seconds. Try to read it through. Launching the bubble launcher in 3, in 2, in 1. No, for this one, for the arrow, it is only indicated when we draw it. But when we do the resultant arrow for vector, it's always 1 arrow upwards. Alright, then it's 1 arrow. Okay, very good. Good job over here, guys. Keep it up. Let's keep up the notion, keep up the drive. Glad you got it, Denise. Alright, the class is more active. I'm liking this. Perfect job. Okay, last 10 seconds down. Last 10 seconds down. 3, 2, 1. Alright, most of you all got it. There's a little confusion. Let's take a look over here. Most of your answer. Aha, take note. Some of you answered wrongly. Let's take a look. PR plus RS. This is PR. This is RS. What is the overall vector? I start from P, I go from P to R, R to S. So therefore, my overall vector should be this one. Again, some of you answered number 4, but take note, it should be number 3. Remember my vector, the left it's the initial point. So the left is the initial point and the right is the ending point. Alright, let's take note from there. Okay, now, but good job over there. Most of you got it. So PR plus RS, this is going to be PS. Now, following up, next one. Okay, with bubble question 2. Let's try the next one. Okay, not so obvious. PQ plus PS. So what law do we use over here? Launching the bubble launcher in 3, in 2, in 1. Let's go. Okay, don't fall into the trap. Let's see what we have. Okay. Take note, PQ plus PS. Okay, this is a parallelogram. Hint, parallelogram. What do we have to do? Okay, PQ, PS. What do we have to do? Okay, last 2. It seems like this one everybody is a little confused, so take note. Now, over here is a parallelogram, so we realize PQ. Travel from P to Q. I'm stuck at Q, so what do I need to do? This vector, if you realize, is equals to this one over here. So now I can travel P to Q, Q to R. So what will I have? Overall, green vector P to R. Okay, so just remember, this is how I denote my vectors over here. Always remember of traveling. Okay, direction travel. How do I make sure I get from the initial point to the ending point? Okay, in this case, P to Q, I cannot travel because P to Q plus P to S, but this is equals to this. So therefore, I have my vector PR because PS is equals to QR. Okay, that's the thought process behind it. Okay, that's the thought process behind it. Okay, so for those who have answered the other one, which is this way, take note, this is not correct because it's P to Q, Q to R. I'm stuck here. Okay, I hope you guys got it better now because this is PS. Okay, always remember P to Q, I cannot travel anymore. Alright, let's see whether we have more. I think we do have more. Alright, this one is a little bit more confusing. Now 3 vectors. Do we have to do any rearrangement or anything? Take a close look first. Launching my bubble launcher in 3, 2, 1. That's why it's 1 minute long, alright? That's why it's 1 minute long. Okay, so take note. This is, be very careful whether it can be done or not. Okay, my first response. Look very carefully. I have QP. I have SR. I think if I draw the last one, it's quite obvious already. Yeah, there's a lot of hints over here given. I have QP. I have SR. I have PS. What do I get? Alright, very good. I think seems like once I draw it. Again, keep it a habit, guys, to draw out my vector. Again, if you realize, if you're not able to solve it, draw it out, and then from there you can see whether we need to rearrange certain terms or not. Last 5 seconds. 3, 2, 1. Okay, this one a bit much better, alright, because I think you all realize that we can actually do it, but we actually have to do Q to P, P to S, S to R. Alright, so just one way to think about it is to see whether the endpoints, there's any other common vertices. In this case, there's a P, and then the endpoint for S, there's a S, henceforth I can pair this way. So step by step, QP plus PS, I get QS, QS to SR, I get QR, which in this case, going here to here to here, what's the overall direction? This way. Okay, so I hope this is a little bit clearer now for the directions in terms of adding vectors. Alright. Any questions, or in fact, let me initiate a feedback to get whether you all understand before I move on to the next one. Okay, so it's a little bit yellows and greens. Okay, that's still good. Anyway, if it's not clear, there's a Q&A. Just let me know if you all need any queries there. Okay, I'll just wait a few more before I move on to the next one. I'll just wait for maybe 20 more seconds. Okay, now, I think it's good. There's not really any red notion there. But for those yellows, I hope it's a little bit clearer if you review the video and take note of my pointers of what I said. Okay, now, next one. Negative vectors. Now, first up, let's go step by step. Let me test you all. And it's a bit of a refresher. A, B. How do I represent A, B as a column vector? Come, write your responses. What is A to B? So take note. A, it's 4, 2 as a coordinate. Let's take note. In this case, let's write as coordinates. A, it's 4, 2. B, in this case, it's going to be, let me see, -2, -5. I want to go from A to B. So take note. I want to go from A to B. Very good, Denise. That's good job down there. Anybody else wants to try? Take note, I want to go from A to B. So I'm going in this direction over here. A to B. Okay, Ian, you want to give it a try? Take note, I'm going from A to B. So A to B. So how do I read these column vectors? We call this the first lesson that we done. What's the right? Very good, Ian. That's good job down there. So realize what happens? I actually have to go 6 units down, 7 units left. Remember, down is negative, left is negative. So overall, it will be negative. Now, how do I then represent BA as a column vector? So right now, I'm going the other way. So I just change my arrow. B to A. So what will be my column vector down here, guys? What will be my column vector? Okay, what will be BA? Okay, give you some try. What will be BA over here? Okay, let me give you some hint. Okay, let me use a highlighter to make it clearer. I'm going up now. After that, I'm going right. Up and right. What is the number of units going up? Very good. Very good thing. Okay, 6 is going up. What is the units going right? Also can write them up, but then we try to go for certain order because against direction to go right. It's not very intuitive. It's like, let's say you're halfway in the air, then you jump, then you try to see how you get from there, then you go up. So also can, but we try to go from up and right to make sure it denotes a certain direction that it goes. But then again, yes, right then up is also okay, but it can be a little bit confusing. Okay, 3 wrong, very good, is 6 to 7. Okay, so in this case, we go 6 up, positive, 7 right, positive also. Okay, but Denise, just make sure we go in the direction that it makes sense to go from B to A in my straight lines. Alright, I hope that is clear, Denise. But now let's see, what can we do about the vectors AB? Okay, what do I mean? Okay, so if I go right first, you realize from B, can I go right? From B, can I go right? Let me see, take a look. Oh, wait, let me take a close look. B is... Oh, I'm so sorry. This is 7. This is 6. Alright, thank you for the note. Alright, because you have to take note. B, I need to go where? I can't go right first, right? I need to go up. So that way, to go up first, and then I go right, it's more sensible. Because if I have to go right, if I go right, there's nowhere for me to go right. Actually, there is. Sorry for that. Yes, Denise, I get what you mean. You can go the other way as well. You can go right. You can go up this way. Yep. Forget what I say. You can go right them up, but in this direction. Yes, you can go right them up. Okay. Sorry for the confusion. Good job over there, Denise, for pointing out. Thank you for that. You can go right up, in this case, 6 and 7 as well, in regardless direction. So if you want to go in this manner or in this manner, it is also okay. Alright, so I hope I clarified anything, Denise. Okay, so you can go either way. Alright, either way, it's fine. Yep, no disadvantages here. Yeah, that's right. Okay, so blue, it's 6. Red, green is 7. Alright, sorry for that. But now, how do we notice about vectors AB plus BA? Okay, I might go right over my head, so I need to take note. Now, in this case, AB, we know is -6, -7. But let's see some magic here. If I take out a negative sign, you realize what 6, 7? 6, 7 is BA. So, if my vectors are negatives of each other, they have this relation. But what do you realize about this relation? Or if I write it the other way, what is the relation over here? First thing, do they have the same magnitude? Do they have the same magnitude? Yes or no? In this case, yes, they have the same magnitude. Take note, why is it negative? -6, -7. If yes, that's good, Royden. They have the same magnitude. In this case, to answer Fionn, why is it negative? AB, -6, -7. I can take out negative on both sides, right? So that's why if I take a negative on both sides, I have 6 and 7 left. Now, what is 6, 7? What do we go through? It's BA. So that's why AB is minus BA. Henceforth, the relation over here. Does this make sense now, Fionn? And in this case, for BA, if I have to do it the other way, if I multiply by a negative sign, okay, BA, if AB equals to BA, I multiply negative to both sides, I get the other equation as well. And yes, Denise, I understand my head is blocking, so let me shift a bit to the side to show you this. Right, sorry about that. Let me just write it a little bit more nicer to have the other relation. Fionn, is this clearer? Is this okay? Because if the first one is okay, the other one over here, I just have to multiply negatives to both sides. Okay, is this clearer, Fionn? Okay, I hope this is okay. Yep, that's good to hear. Okay, now, what does it mean over here in terms of negative vectors? If AB is A, then BA, you realize it's just the opposite direction. Remember what I say? Same magnitude, but I forgot to mention, sorry about that. It's same magnitude, but you realize the directions is totally opposite. Opposite directions. That means if I were to switch my vertices, my direction switches. It's the opposite direction. So therefore, in terms of negative vectors, if I switch my vertices, I switch the letters, it just means that my direction switches the other way with a negative sign, what we went through just now. Henceforth, it is going to be this way. Alright, now with work example, how does it look algebraically? If AB is negative 7, 10, find BA. So BA we know is just a switch in vertex from AB. So therefore it's going to be negative 7, 10, henceforth 7 and negative 10. Alright, I hope this is straightforward. That's very nice, Ian. That's very good, straightforward over here. Let's see how we solve for bubble question number 5 again. 30 seconds, let's see how we do it. Launching the bubble launcher in 3, 2, 1, and let's go. Alright, let's see how we fare this. This should be okay. Very nice. I see all the response streaming in already. Very good. Alright, just take note. Be very careful when we multiply negative. What should it be? Okay, last 15 seconds. Last 6 seconds. Again, we know BA is negative AB, so what should we have? Alright, very good. Most of you got it right. So let me just refresh. Negative 6 and negative 11. Negative side should go up and down. So that's where I have these notions over here. Alright, so that's why my answer is number 4. Alright, so I hope you got the understanding, and henceforth, when we talk about subtraction in this case, since we learn negative factors, what does it mean to subtract first? Let's understand algebraically. Again, A minus B, let's give it a short refresher of our matrices. What it is at the top. What should I have at the top? What is at the top? Very good, Zing. Very good, Ian. I'm going to have P minus X henceforth at the bottom. Very good, Denise. Awesome job. Why is a set sign? You got it correct. Why is there a set sign? Q minus Y. P minus X, Q minus Y. Good job, Ian, Denise, and Zing over there. Perfect. Now, following up even more with a work example. Suppose I want to find BD. Okay. Now, this is quite maybe a little hard question to see. But let's take a look. I have these 3 vectors given. But I realize, I only need to find BD. So let's take a close look. Which 2 vectors do you think will give me BD over here? So in this case, it might be a bit hard to type. So let's say this is vector A, this is vector B, this is vector C. Which 2 vectors is going to give me BD over here? What are the 2 vectors that are going to give me BD? Alright, I have one answer. First and third. Anybody else? Okay, so I'll give you all something to think about it. Okay. So how do you think I get this vector over here then, Zhi? AC. I want BD now. Let's think about it. Remember when we link vectors, we have to find out how to get to B to D. Yes, correct. Denise, that's actually one thing. We actually have to switch it. That's good. There's something that you think over here. One hint over here. I want to get from B to D. BD, B to D. So how do we form over here? Very nice, almost there, but the sign is not correct. You are getting it, Zing. You are getting it. But in this case, instead of BC plus DC, I actually need to do, okay, take note, BC plus CD. But how do I get the CD? That's where negative vectors comes in, because BC plus minus DC. Makes sense over here? Because I have DC, but I do not have CD. But I know if I go from B to C and C to D, I will get the answer. How do I switch it? Denise has given me a point. CD is negative. To switch the direction, all I need to do, change the alphabets, like cut Q, so cut the Q, and then add negative sign. So that's where I have 8, negative 3, minus, that's where I have my subtraction 2 and negative 7. Yep, that's right. I'm getting the response here. That's good. 8 minus 2 minus 3 minus 7. This is going to give me 6, 4. Okay, so it's a matter of knowing what vertices to use and pairing the vertices in mind with them there. How do we switch it? Okay, so right now with this particular notion, bubble question 6, again, this is a little bit longer. Okay, now let's take a look. Why first one cannot? I have B to A. I have B to A. Is there any way for me to get from A to D? I think that has the answer already. Yeah, that's right. So in this case, the first one is out. Cannot use. Second one, B to C. Is there any way for me to get to C to D? There's a C here. There's a D here. So, I can actually get that, but how? Yeah, that we can get that, but how? I need to revert this, right? So I need to have BC plus CD. But CD is what? Learned it before. If we flip it, I get DC, but I just need to include a negative sign. Then you slowly form from there. Alright, so the directions over here actually matter. And again, bubble question 6. Now I want AC. Is it the same question? Or it's a different question, but you realize the vertices are the same. I'm playing with the vertices again. Let's see how we get it, guys. Alright, launching the bubble launcher in 3, in 2, in 1 is a little bit confusing. But let's see whether you can do it. Let's go! Alright, okay, there's a little bit confusing over here. Again, I want to get AC. I want to get AC. But how do I do it? What are the two vectors I should use? Alright, I have the responses down there. Very good. What are the two vectors I should use? Okay, and how should I form it given with the vectors here? AC, so what are the vertices I have? Let's see, okay, very good. I'm getting some response over here. That's a good sign. Last 10 seconds. Try your best, guys. Okay. Take note, I think some of y'all have a mixture of two responses. Launching in 3, 2, 1. Okay, I'll go through this. Don't worry about it. This is a little confusing. I'll go through this. Now, AC. I have BA, I have BC. So you realize, let's picture this. I need A. So definitely this vector has to come out. And then I A to B. Now I from B, I need to get to C. So that's where I need BC. But you realize, how do I get BA then? Let's recall AC. I can get from A to B, B to C. With the pairing in your mind. But now, how do I get it? How do I get my BA out? AB is negative BA. And that's where we can solve from there. Alright, this is a little bit tough, I understand, but that's where you have to realize what other vertices we can use to form my vectors here. Alright, so from here, let's solve it, and then you realize it's to sum it. 5, 7. Some of y'all forget to multiply by -1. Very important here. And this gives me 12 and -3. Alright, this is a little bit tough in terms of the direction. So if you need further queries, okay, read up a little bit from the recording if you have some time over here. Okay, now, what does it mean when we subtract vectors? Okay, let's see whether the animation is there. Again, it's not here. So again, sorry for that. Let me do some magic to actually add the animation first. Stay tuned, just give me a little while to add the animation accordingly. I don't know why it is not there. Don't worry about it, it's going to appear in a while. Just give me a while, but take note, try to review what I have over there. So just give me a little while to set certain stuff. Don't worry about it. Okay, give me a while. Okay, I am actually... Okay, welcome back over here. Alright, now what happens if I were to add my negative vector? What does it mean? Now, when I add a negative vector, what it means over here is this. Okay? What I mean to subtract vectors. Okay? So again, this follows the notion. Try to picture. Now, that is what I've been doing so far with the bubble question. Now, I want to go from A to B. But you realize to go from B to D, I'm stuck. This arrow is sort of blocking. I'm stuck. So what do? Okay? I can't get a resultant vector, right? There's no way. So what I do, I go back. Okay, I need to switch it. Now to switch it is to multiply by the negative side and my vertices switch. So now what I'm doing, I'm able to go down. And henceforth, this actually gives me P minus Q. Okay, so the subtraction of vectors is not really subtraction, but I'm adding a negative vector over here. In this case, it's going to actually be A, B minus DB. Okay, this is the notion. Because just now, if you refer to the video, Okay, it's minus BD. Let me see. AB minus DB. Okay, minus DB. Okay, if I switch it around, it's going to be the opposite. It's going to be minus DB. Yes, minus DB. Okay, to switch the direction around. Okay, same notion over here. Alright, so right now, how do we actually draw the negative vector? Similar notion to what we did for the investigation. First, we draw the vector A. Okay, so how we visualize this? Okay, it's vector A. What we do, draw the negative vector. Negative B. From there, we get A minus B. Okay, but what sometimes is given to you is the vector B. So sometimes what is given to you is this direction over here. A, B. What you need to do on your side is recognize A. I can go from A, but I'm stuck here. So you need to switch the direction and my magnitude over here. No, so just the direction, not the magnitude, just the direction. Okay, and then add a negative sign to give me this overall vector. So draw vector A. From vector A, you draw minus B, and henceforth, this is the overall direction. So this is what it means. And now, what is the notion of triangle law of vector direction? In this case, two vectors, A, another way, and B. Now, what is the overall vector? You realize from the video just now. How do I draw? I want to go from A, but I want A minus B. So what I need to do? You realize, oh, I actually need to start from the endpoint of B. Why so? Again, if I were to flip the direction, endpoint of B, or in this case, if I were to flip it, B to A is my vector A minus B, or in this case minus B plus A. Is the same notion. Okay, similar notion. Minus A plus B, same notion. So the notion of taking the endpoint of B to endpoint of A is the same direction over here. That's the notion. Okay, so I understand it's a little confusing, but more or less try to review the recording to understand what it goes by here. Okay, now I just have one last work example. I'm gonna exit the bit, so for those who need to leave by 3 o'clock, you can do so. But what happens for those who are willing to stay, just follow me from there. Okay, now AD minus AC. AD minus AC. Now let's take a close look. AD minus AC. What does it mean? Again, AD. I should have a vector, right? So let's draw AD minus AC. Now, let's not confuse ourselves first. What's minus AC? Minus AC. Let's draw it out. Minus AC, we call. Minus AC. Okay, first I draw the vector. It's just AC, but in the opposite direction. Make sense? It's just AC, but in the opposite direction. So I have CA. So therefore, you realize minus AC. Draw it out. I'm going to have plus CA. So from here, you realize, if I have this, what is my overall vector, guys? If I have to make a rearrangement in this case. Right now, responses, what's the overall vector where I have? Almost there, Denise. It's not this. It's not that one. Very good, Ian. That's actually correct. Very good, Royden. Very good, doing perfect. Denise, you want to try again? Right now, my direction. Look at my arrow. It's actually going to be from CD. Yep, that's right, Denise. CD over here. Alright, make sense? Okay, now, let's move on. Second one, a bit hard. BC plus DB minus DA. Again, with the minus sign, what happens? We try to actually draw it out. Again, everything, if you draw it out, is actually clearer. So what happens? Again, first, BC, DB, and DA. Okay, minus DA. Take note. When we draw minus DA, we picture. Okay, minus DA is just DA in the opposite direction. Then the rest, okay, B to C and D to B. So you realize if you draw this out nicely, you realize you're going to get I'm just going to get BC plus DB plus AD. And what do I have? You realize, oh, I start with BC first. But BC, you realize, is going to be, start from BC first. Okay, let me see. Did I draw it correctly? BC plus DB plus AD. Okay, so let's see over here. So, right. Okay, so you realize I have to actually get one vector first. So, I have to start in this way. So, BC plus CD, what do I have? BC plus DB. Okay, it's going to be hard, but you realize if I rearrange, I have DB plus BC. Okay, because BC, you realize I'm stuck. I can't go anywhere. So let's rearrange. Very good. You realize I'm going to get, in this case, DC. That's right. So let me just do the rearrangement first. Doing good. DB plus BC plus AD. You are going to get, over here, DC. Now, DC plus AD, what do we have, guys? You realize again further rearrangement, AD plus DC, because if I were to erase this, out, okay, now it's already 3 o'clock, but I still have some more examples. If you need me to, if you want to stay on, you can stay on. Otherwise, you can view the live recording later. But more or less, that's what we have over here. Okay, how long more will it take? Say about 5 more minutes for the example, and maybe about 4 more minutes for the work example, for bubble questions later. So AD plus DC is going to be AC over here. Okay, last one is going to be a bit tough, so I will just do it for your DA. Okay, now this is actually an example to actually denote. Okay, can we simplify as much as we can? Minus BC, let's try. DA plus AB. Minus BC, again simplify, is just C to B. So let's draw the arrows. Now, DA to AB. This one is quite straightforward. DA to AB. DA to AB. Okay, you realize what's the first vector I'm going to have? DA to AB. So I'm going to get DB. But now, DB plus CB. Am I able to get a vector? Am I able to get a vector? Let's draw out. So I have DB plus CB. Am I able to get a vector? Are you sure I can get a vector, Denise? Very good, seeing DB plus CB. You realize, again, I go from D to B. I'm stuck. DB plus C to B. I'm stuck here. I can't. So overall, sometimes you actually have to look that it cannot be simplified. So this is one rare case where it cannot be simplified. Cannot be simplified over here. Okay, so that's why I recommend you all to draw it out to know that it cannot be simplified. And yes, let me just check. We do have 2 more bubble questions. So if you can stay with me with that, we can stay. Take note, I cannot switch. Even if I were to switch the direction, DB, okay, plus CB. Take note, it's DB plus CB. My vector is denoted as CB. I cannot switch the direction because this is the vector that's given to me. I can't switch it. Okay, I cannot just multiply by negative side. It's a whole different vector already. So that's why I cannot do the switching. Ah, that's right. Yes, I'm glad you got it. But now let's try. Okay, bubble question 7. Just 2 more bubble questions. All right, just hang on with me. Launching the bubble launcher in 3, in 2, in 1, and let's go. Okay, let's see whether you all get it. Over here, take note, don't have a rush. I have PR minus PS. So when you see a minus sign, what's the first thing you must do first? Alright, very good. Awesome job. Alright, keep it up. First step, what must I do? What is minus PS? Alright, last 20 seconds. Take note, what is minus PS first? Get this down and you will solve this quickly. Here again. Let me draw for the last 10 seconds for those who want to see PR and PS. So PR is this, and take note, PS is just opposite direction, same vector. So you realize it's just PR plus SP, and therefore I have SP plus PR. This is gonna give me SR. So my answer is number 4. Alright, answer is number 4 over here. So take note. Okay, now last bubble question for today. Alright, last one for today, and you may take your leave. So let's see how we answer this. Alright, this is gonna be a bit tough. So take note. Try to sort of highlight it if possible in your line. Alright, launching in 3, 2, 1, let's go. Again, draw out my vectors. I have PQ, I have RP, I have RS in the opposite direction. Okay, so these are the lines. I will not draw the arrows because otherwise it's too obvious. So what do we have? Last 30 seconds. Okay, let me draw. For y'all, I have PQ, I have RP, but I have RS, but in the opposite direction. So what do I have? Yeah, this should be quite of more the notion. This should be quite straightforward already, I hope. Last 10 seconds. Alright, doing good. Awesome. Okay, so from here, last 4, 3, last one, let's try to do it. Alright, got it right the last attempt. Awesome. Okay, so let's see. Again, write down PQ. It's gonna be PQ plus, no worries, Zing. Hope this lesson is good. Take care. Bye-bye. PQ plus RP. Bye-bye, Zing. Hope this lesson is good, yeah? PQ plus RP plus RS. RS opposite is going to be SR. So in fact, the piece it nicely is actually going to be PQ plus RP, or in fact, you will rearrange SR plus RP plus PQ. Okay, rearrange according to the vertices. Same technique over here. SR plus RP, what do we have? SP. SP plus PQ, what do we have? SQ. So that's the final answer over here, number 3. Alright, again, it's just the piecing of the vectors carefully, which is what we have learned for today. So, what is the notion we have learned for today? We have recapped some vectors and the notion. And what does it mean to add vectors algebraically and in terms of diagram? Negative vectors, what does it mean to do so in terms of the subtraction and diagram as well? Alright, so that's all for today. I hope this lesson has been good. But otherwise, if you have any queries, I'll be more than happy to stay a little bit longer. But otherwise, stay safe, take care. I'll see you next week. Bye-bye.